We did the doubling problem last time. Maybe take one quick look back at that first example on the top of 33, because that's actually similar to how we're going to deal with the half-life problems. We knew the starting amount, we knew the ending amount. We plugged things in, we used logs to find the power. But remember, the power wasn't the time. What do we call the power with doubling problems? Number of
Durations.
time periods. Yeah, the number of durations that we're dealing with. So in that first example, I figured out it was 1.644 time periods. I need to convert that to years. Well, a time period we were told was 7.2 years. So we'll multiply, and you got 12.822 years. We're going to do something similar in that next example. A radioactive isotope with a half-life of 12.5 days, there we go, is decaying. You initially start with 10 milligrams of the sample. How long will it take for you to have only 1 milligram of the sample left? Hopefully, we remember that we have a formula that looks like this. Y equals A times 1/2 to the x. Good, maybe? Do we know the A?
Starting time?
Yeah, not the starting time, the starting amount.
Yes.
What is it?
10.
10. Do we know how long we're waiting?
No. It says how long will.
That's what we're looking for. Do we know the ending amount? 1.
It's 1.
So we're going to say 1 equals 10 times 1/2 raised to the x. Can you tell if this is just a plug-in problem or a problem where we have to use logs? Logs, because we don't know the power. If we knew the power, we would just plug in. I'm not ready to use logs, though. I feel like I need to do something first. A bid. Divide by 10. So we're going to get 1/10 equals 1/2 raised to the x.
But you can't do 1 equals 5 to this?
Whoa, whoa, whoa. No, you can't do 10 times 1/2 because the 1/2 has a power on it. It has an x on it. So we're not allowed to multiply those things together.
Oh, okay.
I think it might be easier to convert if I switch the sides. So 1/2 to the x equals 1 to the 10th. I'm ready for log form. Log base what?
1/2.
1/2 of 1/10 equals x. If you do the little looping thing, we've got that.
Now you do the.
Go to your calculator. Yep, type that problem in. Let's get an answer on the calculator.
So log 1 divided by 10 divided by log 1 divided by 2. I get 3.321. 92809. You did?
Well, listening to the conversation happening over there, it sounds like we should get about 3.322 when we round it to 3 places. Is that the answer? Is that how long we should wait?
No.
What does this tell us? Time periods. You're waiting that many time periods. So how do we figure out days, years, hours?
It's 12.5 days. Is one.
Oh.
12.5 days is 1 time. Period.
So what do we do?
Multiply it.
You're going to multiply that by how long a time period is. I'm going to do times 12.5.
I got error syntax.
Well, then you type something in wrong. The answer is not error syntax. Should get about 41.524 days. Be careful with the units.
Wait, so it's like when you log it, it's like the log and the actually divided by the other log. Okay, it's not like
So you're going to type this in as log of 1/10 divided by log of 1/2.
so wait, where is it going? Why is it 1/10 is bigger than like
No, because that's how we always evaluate these logarithms. The log of the thing over here divided by the log of the base. Do you see how that worked? And do you see that that's basically the same as the doubling problems? I want to skip the next example. I want to go on to the next page, page 34. Please read the first problem. Decide what formula you're going to use. Fill in the numbers, but don't do any solving yet. Can you wait till Ellen gets back, please? Thank you. What's the basic formula? What was that? PERT? Why? Compounded continuously. We need to use the formula A equals P E to the RT. Do we know the P, the starting amount, the principal?
$9,000.
9,000. We know E because it's that 2.71828 plus there's just a button on the calculator for that. Do we know the R? 0.03. And the time?
No, this is how long.
Don't know the time, so that's our T. Do we know the ending amount? Janaea? 10,000. So this is the equation we're getting over here. What do we need to do first before we do anything with logs? Divide both sides by 9,000. It's going to be a messy decimal, but I can simplify that fraction. I can make that a nicer looking fraction. 10 over 9. Yeah, you can leave it as 10,000 over 9,000, but why don't I simplify that? I'm going to switch my sides and get e raised to the 0.03t equals 10 over 9.
How do you know when to do it?
So the only reason I'm doing it like that is because if you want to use Mrs. Eburn's like looping trick, you need the exponential part, the part with the power, on the left. Otherwise, her trick won't work. Log form, right? What's the base of our log? E. Log base E of 10 over 9 equals that power, 0.03t. But what does log base E mean? The same thing as natural. That's kind of why we learned natural logs. That means the same thing as the natural log of 10 ninths equals 0.03t. Go finish that.
On the last ones, I think it would have been like
Okay. Let me see what you're typing. Yeah. Yep. This doesn't. Okay. Then what we need is we need some parentheses. We're gonna have to do. Okay. We need the log of 1/10 in parentheses. Okay. You know what? We need parentheses. We need to do a log of 1/10 in parentheses divided by a log of 1/10. We need some parentheses there. Okay, the natural log of 10 ninths. Can you get 0.105? Yep. Divide by 0.03. Remember, not really 1.05 divided by 0.03. We're using the much longer version still on the calculator. And I'm getting 3.512 years. One more on the notes. Next example. No, because here I want to know how many years. If I want to know in what year, then you'd have to round. Otherwise, decimals are fine. Next example. Read it quickly. It's 2 sentences. Do you know the starting amount? We know the starting amount. Do we know the rate? 4%. Do we know the time? We don't know the time. That's what I want to figure out. Do we know the ending amount? I didn't tell you it, though. Aha, it's tripling. So you can figure out the ending amount. Plug in those numbers, see what you can do in this one. Yes, because we're told it's an annual interest rate, so we're talking about how long in years because of that. Oops. Can we get 27.465 years? Questions on these? So this is it for the unit. Please take out a piece of paper, and I'm going to try a couple more word problems.